Okay, guys, so let's go ahead and take a look at this problem. Hopefully you all got through it. So it said we were talking about Ag2SO4 and will it precipitate form. And so I went ahead and I wrote very messily my Ag2SO4 equation, right? I broke it up in Ag plus and SO4 2 minus, and I remembered to balance it, so I have the two Ags up there. And then I looked up the KSP in the appendix, and that was 1.5 times 10 to the negative fifth. And then I went ahead and wrote my Q, which was the Ag plus squared and the SO4 2 minus. So I'm just going to try to change this pen a little bit. Maybe if I make it thicker, it will be easier to write neater. Okay, so now the next step is actually calculating these concentrations. They did give me an Ag solution and an SO4 solution, but remember, like last time, I'm mixing the solutions together. So I have to recalculate the concentration. So I'm going to start with the 100 milliliters of AgNO3. And I'm going to go ahead and just, like always, milliliters to liters. Go to liters, so was it 0.05? Yeah. Moles, right? Liters to get to moles through molarity. So that was my molarity that was given. This was AgNO3. And then it's a 1-to-1 ratio. And I get 0.005 moles, I think. And I'm going to divide that by crap. Okay, there we go. 0.110 liters, right? So are you guys shocked that it's 2:59 a.m., by the way, because that's just what popped up. One day I will get my life together. Let me just make sure this calculation is right. 100 divided by 1,000 times 0.05. Yep. And then when I divide by 0.110, sorry, did I already explain that the 0.110 comes from the fact that I have 100 milliliters of one thing and then I'm mixing it with 10 milliliters of the other. So that's 110 milliliters, which I convert to liters. And that gives me 0.045 molar for my Ag plus. I'm going to come down here and just quickly do this again. This time, what is it for Na sodium sulfate? My concentration, 5 times 10 to the negative second. Moles per 1 liter. This was the Na2SO4. But all I care about is the SO4 part, so 1 mole to 1 mole. Let's see what we get here. Okay, so I'm getting 5 times 10 to the negative fourth. Oh, so that's just off by a factor of 10 from the top one. So that should be, I think, 0.0045. But since it's 3 in the morning, let me plug it into my calculator. Okay, good. 0.0045 molar. And this is my concentration of SO4 2 minus. Now I'm just going to take these two concentrations, plug them back in here. So this is going to be 0.045 squared times 0.0045. And I get, just doing it up here, times 0.045 times 0.045. I get 9.2 times 10 to the negative 6, which, as you can see, is less than my K. So for this problem, because I have the 9.2 times 10 to the negative 6, that was my Q, and my Q is smaller than my K, then no precipitate is going to form. So Q is less than KSP. So no precipitate. Okay. Okay, cool. I have one last problem that I just want to do with you guys today. And then if there are any questions, you guys can talk about them. Otherwise, feel free to use any leftover time to work on problems or study. Please don't waste this time though. General equilibrium and KSP exam is quite difficult, so you want to make sure you can get through as many problems as possible. So if you use your time today and then again on Tuesday, hopefully you won't have to feel stressed over the long weekend. Okay, so what problem did I want to do? I wanted to do the one that you guys did for homework that people had questions about, but I don't know what problem that is. So let me hit pause and figure it out, and then I'll come back. Okay, found it. So it was problem number 73 from the book. So take a second to make sure you have your book out so that we can look at this problem. I also forgot about the AP problem I assigned last night for homework. We'll see how we're doing on this video. I don't know if I can make another one. Also, you're probably tired of watching them. So anyway, let's take a look at 73. A solution contains a 2 times 10 to the negative 4th molar Ag plus and blah, 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 P2, Pb2 plus. If NaI is added, will AgI or PbI precipitate first? Specify the concentration of I minus needed to begin precipitation. Okay, so this is like the problem that we worked on in class on the quiz. So this is a will it precipitate first situation. And when you have that situation, ultimately what you're going to be doing is calculating the concentration at which the equilibrium is reached. And so then really you know that a tiny bit more would cause the precipitate to happen. So looking at 73, it says that our two options are AGI or PBI2. So let me just scroll up here. This is 1773. And we are considering AGI or PBI2 as our two possible precipitates. And they gave me also in the problem the KSPs for both of those, right? So KSP equals for AGI, they said 8.3 times 10 to the negative 17th. And for PBI2, it said 7.9 times 10 to the something. I gotta look again. KSP, 7.9 times 10 to the negative 9. Okay. And we can also know that Q is going to be concentration of Ag plus times I minus. Everything is in a 1-to-1 ratio there. But over here, we're going to be doing Pb2 plus and I minus squared because that would become 2 I's. Okay, cool. So I know my concentration of Ag plus because it's given in the problem. A solution contains 2.0 times 10 to the negative 4th. Okay. So, 2.4 times 10 to the negative 4th. So what I'm actually going to do is I'm going to take this KSP value here, and I'm going to solve for the concentration of I. What does this mean? This means that at whatever concentration of I solve for, that is exactly when the AGI solution, the solution would be saturated in terms of AGI. So a tiny bit, even like 1 millidrop of I on top of that would cause the precipitate to form. And so I can go ahead and solve when it reaches equilibrium, really to indicate when it will precipitate. This is like when, for example, I don't know if you remember when we were doing delta G problems, we would solve for when delta G equals 0 to figure out when it would switch from spontaneous to not spontaneous. But really, when delta G equals 0, it's at equilibrium. It's neither spontaneous nor non-spontaneous. So anyway, I don't know if you guys remember that. But here, let me just go ahead and solve. 8.3 times 10 to the negative 17th. All wrong on my calculator, trying again. Divided by 2.4 times 10 to the negative 4th. And I am at the problem that I didn't have the square, okay? So I'm getting 3.5 times 10 to the negative 13th. Okay, I'm coming over here. I'm doing exactly the same thing. So this is my KSP. They must have given me a lead concentration in the problem. 1.5 times 10 to the negative 3rd. And the I minus. Hey, don't forget to take the square root when you're solving for the I minus. There. So I'm doing 7.9 times 10 to the negative 10th. Sorry, negative 9th. Divided by 1.5 times 10 to the negative 3rd. Square rooting. I'm getting 0.0023. Okay, so the question is, which will precipitate first? Well, the one that will precipitate first is the one that requires the least amount of I minus in order for the precipitate to form. So I'm solving for this common ion. In this case, it was I minus. And I'm seeing which one needs the least amount of I minus for the precipitate to form. And so here I get that to be AgI. So AgI will precipitate first. Okay, cool. Let me hit pause and just double check in the back of the book that that's right. Okay, so I just checked in the back of the book. I was just a little bit off because I'm sure you guys caught it already. This is actually 2.0 times 10 to the negative 4th, which ultimately should make my answer 4.2 over here. That should be 4.2. I'm sure you guys caught it. If I was there, you would have caught it for me. So 4.2 times 10 to the negative 13th. But definitely AgI does precipitate first. Okay, awesome. So I'm going to stop there, and you guys can spend the rest of your time working on these KSP problems or any other problems. I do want to go over 1985 with you, but I can do that when I get back. Or maybe a good use of your time would be to work that out with each other if you haven't already looked at the key and stuff like that. Okay, I hope these were useful. I hope people didn't fall asleep. Carlo, I'm looking at you. Well, I would be if I was there. All right. Yeah, cool. Have a good weekend, you guys.